Evolutionists have a lot of fun with the whole idea that if God created the eye, he got the film in the camera upside down. I guess today we'd say he got the CCD in the camera upside down, the light-sensitive layer. And it doesn't appear to be that way. When you look at the eyes of all of the vertebrates, there are no exceptions. If you have bones, you have a camera-type eye, and the iris, that light-sensitive layer that would be comparable to film or CCD, does appear to be inverted in the sense that the light-sensitive cells, the rods and the cones, you might think would point towards the light. But instead they point away from the light into the choroid of the eye, which is a highly pigmented and very densely vascular layer, rich in blood. It turns out there are good nutritional reasons for having the retina upside down. These rods and cones and the photoreceptor cells have a very high metabolic rate, have a very high need for oxygen, blood, nutrients, what have you. And to have them tucked in and bathed in that blood-rich choroid makes sense. What makes less obvious sense is that the light now would seem to have to go through the whole layer of the retina. And there are a lot of things in the way. The retina is arranged like a layer cake. There are layers of cells and layers of fiber tracts. And you would think photons of light going through all of this part of the retina would bounce around, get absorbed, scatter, and that this would result in poor light sensitivity in vertebrates and in poor resolution, the ability to see clearly and sharply. If we just look at what is the situation in vertebrates, that doesn't appear to be a problem. For example, eagles are vertebrates, and I'm told they can see a fish just under the surface of the water up to a mile away. As we would say, that's a pretty good set of peepers. As for sensitivity to light, we know neurophysiologically that we can respond to individual photons of light. So it doesn't appear that we take a hit on the upside-down retina as you might think we would. We get our nutritional advantage of having it tucked into the choroid of the eye, facing the wrong way from the light coming in. But we don't seem to suffer any loss of resolution or light sensitivity. In fact, the human eye is what we call refraction limited. By that I mean it's limited by its optics, not by its retina. So if one were to improve the retina, say make it twice as good, we would experience no improvement in vision because our lens and cornea, which are, by the way, both lenses, the lens and cornea would still be our limiting factor. So as I say, we're refraction limited. I used to talk about a cell in the retina when I taught in the medical school. This particular cell, we had no idea what it did. And this cell was the only cell in the retina that went the full thickness. All of the others are, as I say, the layer cake. But this one cell, Mueller's cell, was like a tree trunk. It went the full thickness of the retina, and it was confined largely to the fovea, where we see things sharply in the middle of our retina. And I would tell the students, now that you know the name Mueller cell and you know what it looks like, forget about it. We've known about it for 200 years. We don't have a clue what it does. Well, we know now. It turns out the Mueller cell is a living fiber optic. So light coming into our eye, entering this fiber optic, can travel close to 186,000 miles a second, which isn't going to take too long to get across something the thickness of refrigerator shrink wrap, which is about the dimension of the retina. And as long as the input and the output of these fiber optics are in register in the middle, it could snake all over the retina. It wouldn't make any difference. In fact, it doesn't, but I mean, it could theoretically do that. So our problem is solved now. We know that the Mueller cell, among other things, it belongs to that group of cells called glial cells in the eye, supporting cells. But we know that thanks to that Mueller cell, we do get the light across very nicely, and it's brought across without being bounced around by all of the things that are in between. I think maybe it'll be quite a while before evolutionists quit talking about the upside-down retina. It's interesting, they point to things that they think are wrong or defective, or what they call bad design. The upside-down retina is bad design. Apparently, their argument goes something like this. If a design in a biological system is not a good design, in my opinion, it therefore must not have been designed at all. But that doesn't logically follow. I mean, the cup holder in my car is poorly designed. I'm convinced of it. It has about 10 moving parts, all plastic. And it elevates the cup so you can get a hold of it a little better. But one day getting into the car, I just bumped it with my elbow a bit, and now my cup holder doesn't work. I would say that's poor design, but have I established that there's no design at all in the cup holder? And yet this is the kind of argument I hear a great deal. Another is the recurrent laryngeal nerve. Oh, yes, God got it all wrong. It goes from the vagus to the larynx, and in our body it makes a loop down, loops around our aorta, and comes up again. And you can imagine how long a loop that would be on a giraffe. It's several feet. Evolutionists say, where's your God? He should have run the nerve right straight across, but instead he looped it down around the aorta. But they disregard the embryological development that results in this loop. It's rather like you're taking your dog out for a walk with a leash. And if the dog runs around your legs twice, you'd be making a kind of a long circuitous route between your end of the leash and the dog's end. But that's not the way you designed it. That's what happened when the dog ran around your legs. And so same thing is happening. Embryologically, that nerve was a straight path from its source into the larynx. But as the body became longer, crown rump length increased during the development of the embryo, that vessel that is going to form the aorta hooks the nerve, the laryngeal nerve, and pulls it down into a loop. So the embryological developmental mechanics explains why it is that way. But evolutionists will, I guess, forever try to find things that they think are poorly designed. But we need to be careful, particularly if we say something has no function at all. What's the difference between no function and we simply don't know what the function is? We need to be careful there.